Hello everyone, this is Chris again, and this is the second video in the Learning AutoCAD series. This video is going to go over line work. It's going to go over the basics of line work, specifically how to draw line work, and really basic modified tools for line work. Also, I will be going over what grips are and how to use grips to your advantage. I'll be going over analytic and geometric properties of line work and some basic navigation tools. Okay, so let's start with the basic navigation tools. How to use your mouse is a good start. If you're not using a mouse and you're using a trackpad, it's still possible to use AutoCAD. It's just slightly more of a pain. There are typically three components to navigation in modeling software. There's the selection index, the pan index, and the resolution index. Those are fancy words for saying left click / right click, moving around, and zooming in and out. So in AutoCAD, there are three categories here. Left click selects. I just clicked, and it has this green thing over here and a blue thing over here. So there is actually a difference in the colors. If I had an object and I just hovered over it and then selected it, it would select the object. But there is a difference between the green and the blue. So let's say I have a little bit more objects, and I'll explain what these objects are in a second. If I had the blue, notice how the only things that are actually being highlighted, the only things that are being selected, are the things that are fully encompassed in the blue region. And that's exactly what the blue region does. It's only going to select something that is completely inside of the blue region. And when I click again, it selects the objects. The green is the opposite. It's only going to select objects that touch the green region. So green is good for selecting a whole bunch of things, and blue is good for filtering out what things you want to select. If I were to hold down select, I get this pretty cool dynamic selection. And this is actually called a lasso selection. As you can see, I could do some really weird regions. This is called a lasso selection. And this is blue, so it still operates the same way. If there was a giant blue category that fit all of them, all of the objects, then it would select one of them. And you can do a green lasso as well. Okay, so that's left click. Right click gives you these. When you're not doing it, says repeat command. The last command was line. That was the command that I just did to make all these. I can repeat the last one. I can go into the recent input. I can go into some other options here. But if you're doing a trackpad, if you're on a trackpad, there's no way to zoom in or zoom out. Because on a mouse, you zoom in by scrolling up in the scroll wheel and zoom out by scrolling down. And you pan by holding down, pressing down the scroll wheel. And it follows your cursor. The problem is that a trackpad doesn't do that. Trackpads only have left click, right click, and some pad thing. There is no scroll wheel. So if you want to zoom in or zoom out, you absolutely have to go up here into the view, under the view family, and do one of these scaling, zooming in options. Or you can go into right click and go into zoom. And that's not really a good solution, so preferably you should get a mouse, some sort of mouse, 3-button mouse. Shift does some interesting things for navigation. I said that this is a 3-dimensional model space, but so far I've only done anything in 2 dimensions, X and Y. So if I hold down Shift and I zoom in and zoom out, if I hold down Shift, and I scroll up and scroll down, I'm zooming in and zooming out. If I hold Shift and left click, I just select. If I hold Shift and right click, then I change some of my snap settings. And if I hold Shift and hold down the middle mouse button, hold down the scroll wheel, then I get 3D pan. 3D pan is called orbit. They are a little bit redundant in the naming system. They call it 3D orbit. It's impossible to 2D orbit, so whatever. It's called orbit. This is notice how this is a really smooth orbit. It's following my cursor quite well. If I were to use this over here, this is called the view cube. The view cube is a default part of navigation. You can click on one of these to move to the point that you want to go to, but you can also click and drag it. And notice how this is it does some weird things with my cursor, but notice that it's really a weird, unintuitive, it's an unintuitive thing. Like, it's snapping to various points. So normal pan does not snap to anything. It just follows your cursor. So if you want it to follow your cursor in 3D, you need to hold Shift and hold down the middle mouse button, and that will give you a smooth thing that follows your cursor. I want to go back to 2D. Okay, so we're going to do line work. We're going to do some basic line work today, and line work is two-dimensional. Line work is geometry, things like lines, polylines, circles, arcs, that kind of thing. Those are all examples of line work. The simplest thing you can do with line work is a line. So I'm going to go up here, I'm going to go under line, I'm going to click line. Alternatively, I can click this top symbol, and also alternatively, I can type in line. Almost every command in AutoCAD has a shortcut. The shortcut for line is the letter L. What this is I type in L, and it tells me that that's the command for line. If you type, in other words, if you type in a shortcut and it's a valid shortcut, in the parentheses is the command that it applies to. So this is LAS, and LAS is a shortcut command for the command layer state. LI is one for list, and so on. So let's go into line. It asks me to specify the first point. If AutoCAD asks you to specify something, you can specify things in two ways. You can specify things by left-clicking, or you can specify things by typing in the coordinate. So in this case, this is actually a coordinate, so I need to type in the coordinate. And say I want to type in negative, I don't know, 35, comma 6. Okay, so I type in negative 35, comma 6. So when I select this line, I can select it with the blue region. I could also select it with the green, or I could just click on it. The end point should be where I clicked last, negative 35, comma 6. And the starting point is some weird decimal because I just clicked in random space. So lines are pretty basic. You can input lines by clicking and clicking. You can input lines by inputting a coordinate. So let's say I want to continue from this line. So let's say the same coordinate that I gave last time, negative 35, comma 6. And the next point is, I don't know, negative 42, comma negative 50. How about that? Alright. Okay, that's a really big line. But that's another way that I can input a line. There is a third alternative to input a line, and this is bearing input. So I go into line, I specify the first point. Let's specify the first point as the origin here. 0, 0. And it's 0, 0 because I'm working in the XY plane. If I did 0, 0, 0, that's a little bit redundant. AutoCAD is smart enough to recognize that I'm only working in a plane. I don't need to specify 3D coordinates. Then I'm going to do some weird notation here. I'm going to type in the @ symbol, and I'm going to type in the length of the line that I want. I want the line to be 42 feet long. And then I'm going to do less than symbol, the orientation of my line. So the direction that I want the line to go in. So I want the line to go up and to the right. So up is north. It's going to go north, say 80 degrees. So I'm going to type in 80 with a small lowercase d. And then you have to type in minutes and seconds. So let's just get fancy. Let's say I want to make it 80 degrees and 33 seconds, which is 1 tick mark. And 33 minutes and 21 seconds. 21 seconds, the second, is a quote mark. And then I type in what direction off of north that is. So north, I can go west or I can go east. I want it to be top right, so let's make it east. And then I hit enter. And that's exactly what that was. So it's 80 degrees and some change. And what does that mean? That means that it starts off going straight up, and then it goes down in an east direction, 80 degrees. Pretty cool. So this is a precision input. In the next video, I'm going to go over what precision modify means. But this is a good example of a precision input. This is something that I precisely inputted. I said the length was 42 degrees. The angle was exactly 80 degrees, 33 minutes, and 21 seconds off of the north axis in the east direction. We will be using bearing, which is what that's called, for finding the locations, or not finding, but placing the buildings in the right locations. I'm going to need to input that in bearing notation. But I just wanted to introduce what that is. I have this line selected, and if I deselect it, it just looks like a line. But when I click on it, these weird, let me just drag it over here, these weird things appear. These things are called grips. These blue squares are called grips. Grips are actually quite important because they're the first step in understanding the type of properties that geometry has. So there are two types of properties that geometry has. Well, typically there are two types. There's the analytic properties, and then there's the geometric properties. So the geometric properties are the simplest properties. Where there is a grip, there is a geometric property. This grip is on the endpoint. Endpoints are geometric properties. This grip is on the midpoint. Midpoints are geometric properties. And the analytic properties are the properties that you would use in math class. So I'm going to assume that everyone listening to this video has at least trigonometry as a mathematical background. There are some things that I have to explain using calculus, I will hopefully explain it well enough for non-calculus students to understand. But the analytic properties of a line are its location, its length, its orientation, and the fact that the derivative is constant. For the non-calculus students, the fact that a line's derivative is constant means that it's flat and straight. Okay, that's what it says over here. These are the analytic properties of this line. It gives me the location. The location of a line is judged by its starting and end points. It gives me the length of the line, the angle that it creates, and it also gives me what's called the delta x and the delta y and the delta z. This is a fancy way of saying the change in x, the change in y, and the change in the z coordinates. This is where the derivative information comes from. It took the slope of the line basically from endpoint to endpoint, and that's what this is. The delta x, that's 41 point whatever feet higher in the x direction, and then 6.89 whatever feet higher in the y direction, and 0 feet higher in the z. Okay? So this line has properties. If I want to change the properties, I can only change the properties that are in white. Gray properties I cannot just, I can't just click and type in. But I can click these. Analytic properties are changed by typing in a value. Geometric properties are changed by changing the grips, by modifying grips. Grips represent geometric properties, like I said earlier. Geometric properties change analytic properties. This is a good example. This is the endpoint of the line. This endpoint determines its length. Right here, it has a length of 42 feet with an angle, whatever. But if I make it this, then it's no longer 42 feet long. It's 28.09 whatever feet long. Its angle is also different. Its delta x and delta y are different. So notice that when I changed one of the grips, I'm actually changing the properties of the line, specifically the analytic properties of the line. And this is the starting point. I could do the same thing. And if I click the midpoint, it does this. It changes where the line is. This is something that's very important to understand. The analytic properties of whatever it is that you have selected, the analytic properties, all of them must be affected by the sum total of the grips. Okay, what that means is there are 3 grips here. Between all 3 grips, all of the analytic properties must be able to be changed. So by changing this, I'm changing, look over here to see what changes. Every single thing changes on this list except for the starting point. Its ending point changed because that was what I moved. Its derivative changes, its length changes, and its angle changes. The only thing that didn't change is its starting point. So the starting point can change by clicking the other grip. And the only other thing that's not changing is the location of the line itself. That's why there are 3 grips. Lines are pretty simple. Let's move on to something a little bit more complicated. An arc. This is a circular arc. This is a part of a circle that's been cut out. The part of a circumference of a circle that's been cut out. It asks me to specify a start point. Just like the line, I can specify by left clicking, or I can specify by typing in a coordinate. I'm going to do these by clicking. And then it asks me to specify a second point, so just another point on the arc. And then it asks me to find the third point of the arc. Notice that it's making an arc as I'm tracing. It's tracing an arc as I'm doing something here. Then when I click again, it makes the arc. When I click this, there are five. There are 4 grips right here. And there's a lot more analytic properties. The analytic properties of an arc, of a circular arc, are its position, which is judged by the starting point and the ending point, the center point's position, the radius, the angle that it makes, the length of the curve, the area under the curve, and its derivative. For the calculus students, the derivative of a circle, or even a chunk of a circle, is a linear derivative. So it's actually representing the rate of change as a normal vector from the curve, which is pretty cool. Alright, so what this means is that just like the line, I can change the grips and it will change analytic properties. So notice what changed when I do this. It literally changes everything except for the endpoint. Well, sorry, it changes everything but the starting point. Because the starting point is this one right here, because that was the first point I clicked. Sorry, it must have been the endpoint. It doesn't matter. All of the things are changing except for the other endpoint. This grip changes the radius, and this grip changes the location. The area is calculated because it assumes that there's a radius connecting the center point to each of the endpoints, and it's calculating the area underneath it. Okay, let's go on to be a little bit more complicated. A circle, not just a part of a circle, but a full circle. The full circle asks me to specify the center point. Bam. And then it asks me to specify the radius. The radius is determined as the distance between the center point and where my cursor is. Or I can just type in radius. When I click this, there's 5 grips. There's really only a few things. There's only a few things that are determined analytically from a circle. There's the position, the radius, the diameter, the circumference, the area, and its derivative. That's it. That's all there is to a circle. It's pretty simple. Each of these grips changes the radius, and the grips lie on the quadrants of the circle. And this changes the location. So that's actually pretty simple. The next thing that's complicated is an ellipse. An ellipse is the same thing as a circle, except that it has 2 different radii, not one of them. So to begin with, I specify the starting point. I specify the center point, and then I specify the direction and the length of the other axis. And then I specify the length of the second axis. Now when I click on this, it also has 5 grips, just like the circle. But these grips change not both radii, but their own radii. And this also changes the position. There's actually quite a few things that are analytic about an ellipse. There's the position, there's the center position, there's the major radius and the minor radius, the radius ratio, which is it's an algebraic property. The angle that is produced, this ellipse goes from a 0 angle to 360. In other words, it's a full ellipse. So that's why it shows that. And then there's the derivative information and the area. Cool. Let's get a little bit more complicated. Polygons. I can draw a rectangle, and that's a rectangle. I can also draw a non-rectangle. I can go to the polygon tool and I can enter the number of sides that I want. Let's say 6, because why not? And then it'll ask me if I want to draw it inside of the circle or outside of the circle. It really doesn't matter. If you want to get out a piece of paper and do some math, it does matter. But for drafting, you can just scale these up and down anyways. So I don't even know why they ask you to do this, but I'm just going to pick one. And then it asks me to specify the radius of the polygon. So the radius of the polygon is weird. That doesn't really make any sense, because in order for something to have a radius, what it really should have is all the radii that are the same. But the distance between the center point of this hexagon and all the points along the edge are not the same everywhere. So what it's really specifying is the radius of the circle that is used to make the polygon. And then its orientation. As you see, it's rotating a little bit. Okay. Notice that when I click this, it doesn't say rectangle, it says polyline. And notice that when I click this, it doesn't say hexagon, it says polyline. Well, that's weird. And we're going to get to that in a second. The next thing I want to go over is array. Array is just like a line, except that it's infinitely long, but has a starting point. Here's the starting point, and that's where it is, infinitely long. Arrays are actually pretty useful. I don't use them as much as I should, but arrays don't have endpoints. They have one endpoint, they have a base point, but arrays do not have length. I mean, not a finite length. So the analytic properties of array are pretty basic. There's only two grips. This one specifies where it is, and this one specifies what direction it's pointing. Pretty basic. A spline, we're going to ignore this, and we're going to ignore this. A spline is an amazing tool. I'm going to explain the spline in great detail in next video, but for the purposes of this video, a spline is a type of line and an arc. It's kind of a line and an arc put together, but in a weird way. Splines are very dynamic. They can bend in certain ways. And as you see, I can do some pretty crazy things with this. It doesn't ever have to end. I can just keep clicking. I can get all crazy. It's kind of like spaghetti. And this has a lot of grips. So what I'm going to do is I'm going to draw a simpler one. And each of these grips specify, each of these grips relate to a specific analytic property, but it's not easily readable in this format. So again, I'm going to go over what a spline really is in next video, but think of this as a line and an arc put together. Okay, purposes of this video, we're going to talk about polylines. These two things are polylines, and I want to know how the heck to make one. Some of you have probably been observant enough to realize that this is a polyline right here, but I want to go over how to make one from scratch. That's not this way. So I can go into a line, and let's say that I have two lines. I have this line, and I have this line. And let's say I only want this part of this line and this part of this line. And I don't care about this extra bit up here and this extra bit over here. There's a tool for this. It's called the trim tool. It's under the model, the home tab in the modify section. It's called trim. Do not do this and do not do this. We're working with trim and extend. Trim, I want to select the boundary for trim. Hit, and then I'm going to hit enter. And then I want to select which part of the line that I want to kill. I want to kill this part. And then I do the opposite. Well, I do the same thing, but with the other line. Select the boundary with trimming. That's the boundary. And that's what I'm trimming with respect to the boundary. Which side? Now let's go with that side. Now these two lines are touching. Now they were touching beforehand. They were intersecting, but they were still intersecting at a point. But that point wasn't significant. Now it is significant. Now the point that they touch are their endpoints. So notice that when I select both of these lines, whoops. Let me redo this in a better way. starting point, ending point, and then let's do this. If I go back into trim, I can select both of them at once. This is a quick way to trim. Bam and bam. Okay, so now when I select both, notice now the endpoints. Let me know in the comments if I know what I did, but if you think that you know what the issue was last time, let me know in the comments. Notice that the starting points are different, but the ending points are now the same. Okay, that's pretty cool. So that trim tool, the way that I use the trim tool is that I basically said that all of these, that both these lines are intersecting in a unique way. Okay, so let's select this, and I can move around these grips as such, and I can do the same thing with the other one. So let's select both of them at once and see what happens. I can select this. I can select this. I can select this. Right? And I can select this. But when I select this, they both change. And why is that? So before, when I select one line, all of these grips are what are called static grips. I'm not going to say static grip every time. I'm going to say grip. Okay? There are two kinds of grips. There are static grips and there are dynamic grips. This is a static grip. Everything on here is static. Everything. But when I select multiple objects and the grips overlap each other, that's when they become dynamic grips. This particular dynamic grip is a compound grip, which means that it has more than one grip inside of it. Next video with splines, I'm going to go over some different compound grips, some different dynamic grips that are not compound. And with ellipses, I'm going to go over, in this video, another example of a dynamic grip that is not compound. So this is actually really interesting because I can still move this independently and this endpoint, but the endpoint that they share is no longer moved independently. And what if I wanted this? What if I had both of these lines and I would like to just be able to, I don't want to have to select both of them every time. I would love to be able to select one of them and it's able to select the other one automatically. So a way I can do it is I can go under the Modify section in the Home tab, and I can go down here, and I can go into Join. This joins objects together. So I'm going to select the two objects that I want to join and hit Enter. And now they're the same object, and this object is called a polyline. Think of a polyline as multiple lines glued together at once. But notice that now the grips, some of the grips have changed. This is still a compound grip, and these two are still static grips. But these have changed shape. They've changed size. They've done weird things now, right? Before they were squares, and now they're rectangles. Well, let's compare. I'll just keep both of them selected. When I do this, it changes the component, it changes the line by itself. But when I do this, it changes the line and the other one. So this is an example of a dynamic grip that's not compound. This grip has nothing underneath it. This grip has the endpoint for this line and the endpoint for this line underneath it. This grip is actually two grips on top of each other, which is why they have this property right here. But this grip and this grip have nothing underneath it. So, what's happening? This rectangular, whenever you see a rectangular grip, think of it as a preservation of dimension. Notice that the length of the line right here is not changing when I'm moving it, just like it was not before. It's not changing anything about this line. But because the other line is glued to it, it does change the other line. And that's what these polylines are. Ways to condense multiple line segments together into one entity. So when I think of a rectangle, that's what this is. Now I can select this and make it a parallelogram just like that. Or I can make it crazier than a parallelogram, some rhombus. But so is the hexagon. There are crazy things that you can make them overlap. You can make them do whatever you want. They're just lines. So I'll turn them back into a rectangle line. Just because. Now, what if I wanted to do the same thing with arcs? I have two arcs, and I would like to take this arc and make it into that arc. Now I can do this, and you might have noticed this thing called extend. Under the trim family, there is the extend tool. It's the same exact thing as the trim. I'm going to select a boundary, hit enter, and then select the object that I want to extend. And notice that it continues to curve. That's because it's extending the object. It's extending the curve. And then I want to, well, hold on. I'm going to take this example right here. I'm going to move it over a little bit. I want to do it in two different ways. Then I want to trim because I want their endpoints to match. So now when I select this, it actually successfully changes the grip. It makes it a dynamic grip, specifically a compound grip. Okay, what if I want to do the same thing I did with the lines and turn them into polylines? Can I do that? Is there a poly arc? Well, it's not called a poly arc, but it's actually called a polyline. I can take this, I can take this, I can combine them, and now they're polylines. And look, this is now a square, a rectangle, which means that it preserves that shape. In this case, what's being preserved are the endpoints, and what's changing is the radius. Cool. What if I wanted to do this without having to extend this and then trim it? Well, there's a way that I can do it. It's called the chamfer tool. At distance 0 for both axes, I can essentially chamfer between two objects. Or I can, a fillet and chamfer are the same. Fillet is a chamfer that's curved, and chamfer is just a straight line. As you see, that's kind of what the logo for them is. It doesn't allow you to chamfer non-curvy objects, but you can fillet curvy objects. So I'm going to fillet with a curve, but I'm going to make the curve a radius of 0, and it's kind of cheating a little bit, but it gets the job done. And now I can take this and I can combine it, and I have a polyline. Notice that was a lot easier than what I did earlier, which is extend and then trim and then select all and then do the join. Both fillet and chamfer extend and trim automatically. They do both those operations perfectly. Now, these two tools are a little bit picky. As you see, I kind of forgot that chamfer does not chamfer does not connect two curved segments together. I kind of forgot that. So they are a little bit picky on their requirements, but they're very useful for extending and trimming automatically in multiple steps. So these two things are also polylines. But what if I wanted to take lines and arcs, and I wanted to do something with them? Well, if lines can turn into polylines, and arcs can turn into polylines, then the logic says that so should lines and arcs together. So I'm going to fill it with the radius 0, because that's easiest. And then I'm going to select all, and I'm going to go into the Home tab, under Modify, and then select Join. And now, guess what? It's a polyline. So the same rules apply for the geometric properties. The same rules apply for grips. Okay. Geometrically, think math class. Does this have an area? It should, right? It's a rectangle. Rectangles have area. Does this have an area? Yeah, it's a hexagon. Hexagons have area. These two things are shapes. They should have area. Shapes have area. But what about these things? They're not shapes, are they? So they shouldn't have area. Yet that's weird, because when I click on this, it tells me what the area is. And see, this is kind of a baffling thing about AutoCAD if you don't know what it's doing, because this is not a closed shape. If I told you to take the area of this shape in math, you would look at me and say, Chris, you are insane. The area does not exist. Or it's the entire area of the XY plane, which is infinity. And neither answer is useful to me, yet AutoCAD somehow produces a number that I can use. And see, what it does is it assumes that I have some line connecting the two endpoints. So that's the shape that it assumes when it calculates the area. So to prove this, take note of this number. I'm going to select this, and I'm going to join it. And it's the same number. It assumes that this polyline is what's called closed. As it turns out, you can easily toggle back and forth between closed and unclosed, but when it calculates things that are dependent on being closed, in other words, area requires it to be closed. So when it determines what the area is, it assumes it's being closed. That's a pretty useful thing to know. And polylines are not the only thing that has that feature. Walls and spaces and floors and stairs and other things have that same property. But essentially, this is kind of the thing you got to be aware of. One thing I want to I want to quickly go over some of the consequences of trimming. I have a circle, a bigger circle, preferably, and I have a line, multiple lines that pass through this circle, and I want to trim a part of the circle off. Let's trim the bottom part off. That circle, it was a circle, and now it's an arc. So circles, when they are not closed, turn into arcs in AutoCAD. This makes sense. The definition of an arc geometrically is just a part of the circle. But that's what AutoCAD does. Okay? An ellipse broken up into pieces. Is still an ellipse. And that's because ellipses are kind of weird mathematically or geometrically. They're really weird. They're really complicated. But notice how I used to have 5 grips, and now I have 6. Those 2 arrows, here and here, are another example of a dynamic grip. Basically, the general rule of thumb is that if a grip is not square, it's dynamic. So what this is a really cool grip. I can click this and I can trace the ellipse. I could trace it backwards. I could trace it forwards. I could do what I did the first time and trace it so far forwards that it turns into backwards. Or I could do the same thing to the other side. And see, this is why it stays an ellipse. It kind of needs to. With a circle, if I were to trace a circle, right? Not trace a circle. If I were to trace an arc, then, I can do that. I can trace an arc, and it can go all the way around and around and around and around, but notice that the radius is staying the same, basically. And that's because circles only have one radius. But with an ellipse, radii are a little bit funky. Like, I know what the radius from this point to this point is, and from this point to this point, but I don't know what the radius from this point to this point is. So AutoCAD needs to store this information so it doesn't have to recalculate it every single time. This is why when you take an ellipse and you cut it in a portion, it stays an ellipse. If you're wondering, yes, if you take a polyline and you cut it, it stays a polyline. Duh. Okay. I think this is a good introduction to some of the ideas of line work. I think this is a good start. Next video, I'm going to elaborate on specific kinds of line work and some more of these tools and how they work, and also some of these down here. But for now, I think we can call it good. I'll see you next time.